Hello, and welcome to today's lesson on complex similar shapes. Using your notes from the last lesson, can you show that these two triangles are mathematically similar? As a follow-up challenge, in the following two triangles, angle ABC is equal to angle DEF. Calculate the length of E and F. As a reminder, use your notes from last week and that step-by-step guide to help you. Pause the video here to give it a go before moving on to the answers. Now with that first question, I thought it'd be helpful to share the mark scheme because it is an exam question. You get 1 mark for trying to divide some corresponding sides. Remember in last week's lesson we spoke about using maybe a different coloured pen so it's really clear for you and the examiner which sides you think are corresponding. There's also an alternate method, as you can see, using inverse tan to show that the ratio of the angles is still the same, but actually for this kind of question, using the corresponding sides is probably easier. As you can see, there is a final communication mark. You must state a sentence saying that either the sides are all enlarged by the same scale factor or that you've calculated that the triangles have the same angles and the corresponding angles. With the challenge, similar method. First step, obviously identify the corresponding sides from the fact that you knew which angle was corresponding. From there, work out your scale factor, and I got a scale factor of 2.125. I would like to calculate the EF, so I've worked out that I need to do 2.6 times my scale factor of 2.125, which gave me a final answer of 5.525. In today's lesson, we will be recapping what we covered last week in terms of finding missing sides in similar shapes, but also moving on to looking at finding missing sides in similar rotated shapes and also similar embedded shapes. Now, another interesting fact about similar shapes, if you've ever looked at sizes of paper, for example, A4, A3, A5, they have a special property that when you put two sheets of one size of paper together, the combined sheet is mathematically similar to the individual sheet, where the length is √2 times the width, which is pretty cool. It's why you can cut a piece of paper in half and it then makes the next size. Last week we used this step-by-step guide to support us, making sure that we're identifying corresponding sides, checking which way you want to apply the scale factor, using a pair of corresponding sides to calculate the scale factor, and then applying your scale factor to find the missing length. Today we're going to be using the exact same step-by-step guide, but looking at more complex examples. Now with this question, we are asked to first show that the two triangles are similar. Now remembering that we have parallel lines, we know that there are some angle facts for angles within parallel lines. Notably in this question, that this angle is the same as this angle because alternate angles are equal. This angle is equal to this angle because alternate angles are equal, and this angle is equal to this angle because vertically opposite angles are the same. Now because we're looking at similarity and not congruence, it is enough to show that because the angles are the same, these two triangles are enlargements of one another. We're not trying to show that they're the same, so we don't need to say anything about the sides. Now that we've established that these two triangles are similar, we can then move on to finding the missing angle x. Now to do so, I'm going to redraw my triangles underneath and label the information that I have. So to begin with, if I start with the top triangle, I know that I've got R, Q, P, and I've also, the bottom triangle, got R, S, T. Now to help me, I'm going to put the colours back on here again. So I know that angle Q is the same as angle S. I know that angle T is the same as angle P. And obviously I know that angle R is the same as angle R. Once I've established that, I can then label with the information I know. So for example, from the picture, I know that the length RP is 4, that the length PQ is 5, and that the length RT is 8, with X down here. Now that I've established that information, I can then do exactly what we were doing before.
Firstly, notice what goes ahead. So my corresponding sides are here and here. So I know that 4 times my scale factor is equal to 8, giving me a scale factor of 2. I then know that 5 times my scale factor of 2 must give me x, which means therefore that x is equal to 10. This second example is looking at when we have embedded triangles. Now we could prove that these two triangles are similar again, but the corresponding angles this time, because we know that this angle here would be 50, this angle here would be 60, and this angle at the top would be 17. It's a common angle in both triangles. But actually this question just asks us to show what the length of AB is and what the length of BD is. Similar to the last question, I'm going to start by drawing the two triangles separately first and labelling them. So I know that I've got A, D, E. Here I've got A, B, C. Putting on the sides, remember I don't care about the angles, the sides that I want. I know that here is 9 and here is 10. And with ACB, all I know is that this is 15. AB is the side I want to work out, which is X, and BD is a side I'd also like to work out, but at the moment I will just label it up here, Y, for later. Now having a look down here, I can start the process as I normally would. I want to get from this triangle to this triangle. My matching sides are at the bottom here, so I know I've got 10 times my scale factor gives me 15, which means my scale factor is 15 divided by 10, which is 1.5. To then work out x, I know that 9 times my 1.5 has to give me x. 9 times 1.5 gives me 13.5. If I then to go back here, work D, if I know this whole side here is 13.5, DE must be 13.5, take away the 9 that's already there, which gives me an answer of 4.5. Okay, so just referring back up to the question at the top and noticing that if I now have the long side, I just want to work out this missing portion. There's the 4 example.
Now it's your turn. Can you use the notes that you've taken in the examples to find the missing lengths in the following questions?
Okay, time for answers. Now, exactly like we did in the examples, my first step is just going to be to use a different coloured pen to identify which angles are the same. That then makes it really easy for me, particularly with the questions that look like this, where you have a rotation taking place, makes it really easy to identify which sides are the same. I'm then going to sketch out those two triangles. Again, your sketch doesn't need to be accurate or to scale, but what I am going to make sure I do is add on my colours as well, so that when I come to label my sides, it makes that process a lot easier so that I don't make any mistakes further down the line. Having a look back up at my picture, in between purple and green is Y, in between green and blue is 20, and in between purple and blue is 30. On the other triangle, in between purple and green is 12, in between green and blue is X, and in between blue and purple is 18. If I start by trying to work out X, I know I want a scale factor that goes this way. Having a look, I've got matching sides here and here, which means that 30 times my scale factor must give me 18, which means my scale factor is 18 divided by 30, which is 3/5. To then work out X, I know I need to do 20 times my 3/5 to get X, which means that X is 12. Now to work out Y, I could do the whole process again and work out a scale factor going this way, but remember, if you know to get from this shape to this shape, you times by 3/5, to get from this shape to this shape, you need to divide by 3/5. So I'm just going to just use that process. I know that 12 divided by 3/5 must give me y using inverses, which therefore means that y is equal to 20. Having a look at this second example, again, it's really crucial, particularly with these ones where they're embedded, that you draw out the shapes. So if I start by just sketching the triangles, if I start the little shape, I've got a 3 here and a 4 here. With the big triangle, I've just got the 14, and I know I initially do want to work out that full length because that will represent BC. Again, same game, I want to go from this one to this one. Having a look at my corresponding sides here, I know that 4 times my scale factor needs to give me 14, which means that my scale factor is just 14 divided by 4, which gives me an answer of 7/2, so 3.5. I therefore know that 3 times 3.5 has to give me x, which gives me an answer of 10.5. Having a look back up to the question, if I know that this full length here is 10.5 and I've used up 3, I know that BE, so that missing bit, must just be 10.5 take away 3, which gives me a final answer of 7.5.
Now it's your turn. Using your notes and the examples that we've gone through today, can you complete the worksheet linked to this lesson? As an additional challenge today, there is a further question at the bottom of this slide.